Okay, my pre-cal babies, this is Unit 7, Topic 4. This is our last video for Unit 7. Woot woot! So I want you to notice, though, as I begin Example 6, this is a new type of problem. So we are still dealing with using the sum and difference identities, which is why I've got them over here. But now, rather than using the unit circle, we are going to use different values for our right triangle. So if you will recall, when we first started talking about the unit circle, we built it using right triangles, and the reason we call it a unit circle is because the hypotenuse was equal to 1 everywhere, and because of the nature of our special right triangles that formed all of the values on the unit circle, we knew that sine and cosine were going to be specific values along the unit circle. So now we're going to look at doing a problem when we don't have 1 as the hypotenuse and when sine and cosine may take on different values. That's why this is a different kind of problem. So the first thing I want you to recognize is that we have sine theta equals 5 over 13. Well, if you will recall from when we first started trig, we talked about the fact that sine theta is equal to opposite side over hypotenuse. Remember, we talked about SOHCAHTOA, and that cosine would be the adjacent side over the hypotenuse. So we talked about that already. That's going to come into play here. So there's lots of information. Sine theta is equal to 5 over 13. That means in a right triangle, 5 is going to be the side opposite theta, and 13 is going to be the hypotenuse. And then you're also told for cosine beta that it's equal to 4 over 5. So for this triangle, 5 is the hypotenuse, and the adjacent side is 4. So we have two different right triangles that we're dealing with here. Theta and beta both terminate in the same quadrant. That means that since they are both positive, I want you to notice that when you're told theta and beta, that's these two angles, they both terminate in the same quadrant. That means that sine theta and cosine beta are in the same quadrant. And since they're both positive, it has to be in quadrant 1. All right, we are finding cosine theta plus beta. That means we are using this sum and difference identity. So we're using the sum identity of cosine A plus B, where A is theta and B is beta. So I just want you to know that's where we're headed. But before I do that, I've got to use my right triangle math here. So I am going to construct quadrant 1, and I'm going to draw a right triangle in it, and I'm going to label this theta. I'm going to draw another one over here. Label this angle beta. All right, so sine theta, remember sine theta, opposite over hypotenuse, so the opposite of theta is 5, and this is 13. So I need to use my Pythagorean theorem to find the other value. So I've got x squared plus 5 squared equals 13 squared. So that's x squared plus 25 equals 169. X squared is equal to 169 minus 25, which is 144. The square root of that is 12. So x equals 12. That's this side right here. And now for beta, see, I'm told cosine beta is 4 over 5. Well, cosine for beta is adjacent, so that's 4, and the hypotenuse is 5. Again, I'm going to let that be y. I need to use the Pythagorean theorem. (25 minus 16 is going to be equal to 9, so the square root of that is 3. So this equals 3, so that's this side right here. All right, so once we establish that, now we're ready to proceed with what we need. So I've already told you that we're using this sum identity right here. So that means that I need to find those values and write that accordingly. So I am going to replace A with theta, I already told you that, and B with beta. So I am going to have cosine theta plus beta. So that's going to equal cosine theta times cosine beta minus sine theta sine beta. Okay, so I'm done with that now. All right, so now I have to replace, remember on my other problems, I replaced all of these values with what they were off the unit circle. Well, now I'm going to replace them with values that occur in this triangle and this triangle. So cosine theta, well, this is the theta over here. So cosine theta is going to equal adjacent over hypotenuse. So I replace cosine theta with 12 over 13. See how that works? Cosine beta was what I was given in my original problem. I don't need to read it off of anything. It's 4 over 5 minus sine theta. I was also given sine theta at the beginning of the problem. It's 5 over 13. And then sine beta, I'm going to use this right here, opposite over hypotenuse, so that's 3 over 5. And then I just do my arithmetic. So 12 times 4 is 48, 13 times 5 is 65, minus 5 times 3 is 15, 13 times 5 is 65. We are always going to have the common denominator here, so 48 minus 15 is 33 over 65. There we go. I know these are difficult, okay? You have to go through several steps to find these. So let's jump right in and do the next one. So let's look at number 7. I am going to copy this again, so we'll have it down here. All right, so for this one, we're told sine u is equal to negative 2/5. That means we're not in quadrant 1 anymore. U is in quadrant 3, see? Cosine V is 3/4 with V in quadrant 4. So we're finding the sine of U plus V. All right, before I talk about my correct identity, I want to set up my right triangles. Quadrant 3. Well, remember, quadrant 3 is right here. All right, so I'm going to set up a right triangle. It's U, so I'm going to put U right here at the origin. Opposite is -2, hypotenuse is 5. Now, keep in mind that the side of a triangle can't be negative. All right? So the negative just tells me what quadrant it is in. Because remember, sine is your y value, and in quadrant 3, y is negative, and so is x. That's what that tells me. So again, I am going to label this side x and use the Pythagorean theorem to find the value. So I've got x squared plus 2 squared equals 5 squared. So x squared equals 25 minus 4, which is 21. Well, that isn't nice and tidy, so I'm just going to leave it as radical 21. So this is radical 21 over here. And then I'm going to do the same thing for cosine V. It's in quadrant 4. So for quadrant 4, I'm going to use a different color here. So quadrant 4, remember, quadrant 4, your x value is positive, your y value is negative. So you're told cosine is positive. Of course, that would make sense. So I'm going to draw a right triangle here, label this V, adjacent over hypotenuse, so I'm looking for y right there. So again, the Pythagorean theorem, 3 squared plus y squared equals 4 squared. So I know that 4 squared is 16 and 3 squared is 9. So 16 minus 9, so y squared is equal to 7. I take the square root of that, and I get the square root of 7. So this value is the square root of 7. Okay, so I'm going to erase this so I have room. All right, now I'm ready to go. I've got all 3 sides of each of my triangles, and that's what I need because I need to find sine of u plus v. So it's plus, so I'm using this one right here. I'm going to replace a with u and b with v. So we've got u, v, u, v. So I'm going to have sine of u plus v is going to equal sine of u times cosine of v plus cosine of u sine of v. All right, so now I'm going to replace sine of u with the sine of u I was given. It's negative 2/5. Cosine b, of course, I was given that as well. It's 3/4 plus cosine u. So u's over here, cosine's right here, so it's going to be adjacent over hypotenuse, so that is going to be radical 21 over 5. But remember, this is quadrant 3, so this is a negative right here. Sine of v, I'm using this triangle for that. So sine of v is opposite, so that's radical 7 over hypotenuse, which is 4. And again, this is going to be a negative because y, remember, is sine. So this is also a negative. All right, so you have to be careful with your negatives. Negative 2 times 3 is negative 6 over 20 because 5 times 4 is 20. But here I have a negative times a negative, so this is actually going to become positive. So radical 21 times radical 7. Okay, we have to do some math here. 21 consists of 7 times 3. And then when I multiply that by radical 7, I end up with 2 7s in my radical. So the square root of that is 7. So 7 radical 3 over 20. So this ends up giving me negative 6 plus 7 radical 3 over 20. Yipes. I warned you these were difficult. I don't want any complaining.